Hi guys, it's Mrs. Seitz. Today, what you're going to be learning is sort of a build on some things we've learned in the past, but also we're going to be adding some new ideas with it. So I know your favorite thing in the entire world is proof, but I wanted to show you that there's some other different ways that you can actually show a proof out there. So, for example, we've been doing the method called two column proof, okay, where we list our statements and we list our reasons. But there's other different methods out there called a paragraph proof and a flow proof, okay? So, for example, in this proof, we're given angle 5 and angle 6 are a linear pair, angle 6 and angle 7 are a linear pair, and we're trying to prove that angle 5 is congruent to angle 7. Okay, in our two column proof, we would state our given like we normally do. Okay, then we would go through our logical reasoning, like by stating, we'd go build off of the linear pair part by going with the linear pair postulate, saying that we have two pairs of angles that are supplementary. And then we would go with the congruent supplements theorem to get where we want to be by saying that angle 5 is congruent to angle 7 because we have that two angles are congruent to this, or two angles are supplementary to the same exact angle, so therefore they are both congruent to one another. So we have our little two column proof that we're comfortable with. How a paragraph proof works is it's a type of proof that describes the logical argument with sentences. So instead of being set up in two columns, it just kind of explains in sentences what's going on. So it says because angle 5 and angle 6 are a linear pair, the linear pair postulate says that angle 5 and angle 6 are supplementary. The same reasoning shows that angle 6 and angle 7 are supplementary. Because angle 5 and angle 7 are both supplementary to angle 6, the congruent supplements theorem says angle 5 is congruent to angle 7. So that's how a paragraph proof works. Every once in a while, the directions might say for you to fill in some reasonings into a paragraph proof. Just likewise, they might ask you to fill in some reasons to a flow proof. I am going to always ask you to use a two column proof, but I want you to know that these other ways exist out there. What a flow proof does is this type of proof uses the same statements and reasons. It's sort of like a two column proof, but it uses a logical flow connecting the statements but with arrows. So like we sort of have two givens in our proof, and we have two things that are really flowing together with the linear pair postulate. They're all connecting together at the end with the congruent supplements theorem and what we're trying to prove. Okay, so you just have to follow the directions and what everything's given to you, but they sort of all connect together, and we're still getting from point A to point B with a given statement and what we're trying to prove. Okay, the other thing I wanted to touch briefly upon with you guys are some new theorems. So here's what these new theorems are. And remember, theorems are things that have been proven true, and the wording's very important on them. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Okay, so we have to have given to us that we have two lines intersecting to form a linear pair. So we have to have that part. We have to have a linear pair and they have to be congruent. So when I look at my picture, I have the linear pair, right? So the two angles that are touching, right? And linear pair means touching, forming the line down at the bottom, right? And I know that they're congruent because I see right here in red these two lines. So that means the angles are congruent. So if I have these two situations happening, then the lines are perpendicular. All right, another theorem says if I have two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So let's see that one more time. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So complementary, remember, means adds up to 90 degrees. So that means acute, two angles that are less than 90, okay? So adjacent means touching. So that means when I look at this picture here, if I look at this angle portion right here in purple, and if I add the red portion up with it, if the two sides are perpendicular, so they're telling you that part, then they would have to be complementary. Okay, so they have to tell you that these two angles are perpendicular, the purple and the red, for you to be able to say that they are complementary or adds up to 90 degrees. The last theorem that we can use, if two lines are perpendicular, so this line here and then the one that's going horizontal, then they intersect to form four right angles. Okay, so we have the blue angle, and then we have the other three red angles that are given to you as well. But again, you have to read what's given to you to understand if you can use it. So you have to have stated that two lines are perpendicular for you to be able to use theorem 3.3. To be able to use theorem 3.2, you have to have given to you that you have two adjacent acute angles that are perpendicular to be able to make any other type of statement. And then for theorem 3.1, you have to have given to you that two lines intersect to form linear pairs of congruent angles to make up the assumption that the lines are perpendicular. For the second part of your lesson, you're going to be proving with these theorems two proofs.